Ladies and gentlemen, thank you for your attendance. I'm here today to present a part of the study which I carried out during my research at Ecole Nationale Supérieure d'Arts et Métiers, Mohammed University at Rabat. The objective of this work is to perform a comparative study of the doubly-fed induction generator power control using the vector control and fuzzy logic. The presentation is according to the following plan. So the variable speed wind energy conversion system based on a doubly-fed induction generator driven by a turbine and controlled by the rotor is the most widely used system in wind energy. In this concept, the stator is usually connected directly to the grid. The rotor is also connected to the grid, but through a transformer and two bidirectional converters. According to the assumptions applied, the different voltage, currents, and flux become in this form, and the expressions of the powers and electromagnetic torque become in the following form. In this comparative study, we have worked first of all on the active and reactive power control using the vector control method. The principle of this method is similar to that of a DC machine with separate excitation. The active and reactive power depend only on the rotor current. So in this structure, we propose a stable voltage and frequency network. It involves slaving no longer the powers, but more precisely the rotor current. So to correct, we add a complementary regulation loop of active and reactive power on the block, so that each regulation axis can have two PE controllers, one for the power and the second one for the rotor current. For the second method is to perform this control using a fuzzy logic controller. The design of this controller goes through four main distinct stages as shown in the following figure: an inference, a knowledge base, fuzzification, and a defuzzification. The two most significant quantities to analyze the behavior of the system, namely the error and its variation, are chosen as two inputs of the regulator. The output is the increment of the control signal to be applied to the system to be controlled, and the regulator inputs are calculated at time as follows. Also, the control signal is can be obtained after integrating the regulator output. For the membership functions, we have chosen for each variable the triangular and trapezoidal shapes. So let's see now the results of simulation regarding the first method. From these results, it's clear that the active and reactive powers of the system perfectly follow the desired references with a small error on the powers. The stator flux orientation technique has indeed been found to decouple flux and powers. On the other hand, through the simulation results presented by here, we observe that the active and reactive stator powers follow their references values. We have a better tracking of the stator power references, and we can also notice that the measured active and reactive powers follow their references perfectly and with enormous perfect decoupling between the two axes. The response also are without overshoot and almost zero statistic error. So as a conclusion, we can say or confirm that the indirect method with cascade loop allows for an efficient system. It will allows an optimal operation of the power generation system. On the other hand, the simulation results confirm the efficiency of the fuzzy logic control system as a nonlinear control method. Nevertheless, we can still notice a small error in the response of the system because of the adaptation law is not fast enough to detect sudden changes in wind speed. So as a perspective, we're gonna work on the robustness of the fuzzy logic controller with the change of the parameters machine, and work on other nonlinear control to laws to other more powerful controllers. So thank you for your attention.